Okay, if you look along the wall here, remember Andy told you before, all that steel that comes down, it gets fit in between. You see where those steel plates are? The strand goes between those. Depending on the design by the engineer, they may go on the bottom all the way up to the top of the piece there, depending on the height of the beam. And then what they do is they put, how many of you ever seen a movie with planes landing on an aircraft carrier and they grab a cable? That's how they stop. We use those same kind of grabbers, they're called chucks, to hold the strand from slipping through. So we pull the strand by a machine, that's a hydraulic machine over there, it pulls it to that 31,000 pounds per strand. And then they put the chuck on it and it will not allow the strand to go back in. All the way down the line. One strand. So what happens, we pour the piece in here and then within 18 hours, guy comes by with a torch and cuts the strand. And a piece of concrete that's about 350 feet long, or depending if it's 178 feet, all the way down the line, will actually lift up off the bed. Because you're putting all that tension from that strand will go right into the concrete. And then the concrete becomes compressed.
What's the maximum length that you can pour here?
Well, it's not a matter of what we can pour, it's what we can ship. 180 feet was pretty spectacular. And those pieces, as I said, 237,000 pounds were picked up by these two machines here. This is all poured in place concrete. The walls on the outside are all ours. No, tilt up. Oh, that's a precast, that's like swearing at a precast contractor. All these panels were made in those forms that we saw in the other building. They're all precast. Huh? Yeah. Folks, you don't get an idea of how big these things are, but I'm 6 feet. These tires are almost 6 feet tall. These things, each one of these can lift 140,000 pounds without going into its safety factor. So 280,000 pounds between these two machines. As you can see, in the pre-stressed form, epoxy coated bar on the bottom, because that's closest to that'll be closest to the bottom of the beam, and they want to make sure that it doesn't start rusting or anything above that. You see the strand that's inside has already been tensioned. And what they're doing right now is they're putting additional rebar that have to go in there and they're tying it to the strands.
Why are some of the rebars like tilted?
Because they haven't come back yet and straightened them all out.
Oh, okay.
See, what happens is that's what these guys are doing right now. They just put them in loose. They build these as what they call cages. And then when they come down the line, they'll straighten everything out. And then my quality control department will come in and measure everything. Then the state of Illinois will come in and measure everything.
What's in that bucket? What was he applying to the rebars?
Which one are you?
What's in the bucket? Like he was like applying something to the rebars.
He's putting grease. He's putting grease at a certain area because they call that debonded steel, which means they don't want the concrete to bond around the steel at that point.
Okay.
And then what happens is they put grease on it so that when you pour to it, the concrete won't grab onto the steel. Those things that are going across the pieces, this is what they call a box beam on a bridge. They will actually take threaded rod that goes through the pieces and tie the piece that's on that side and this side and this side. They'll bolt them all together and squeeze the bridge together this way. They do this on small county bridges. You won't see that on the big ones on the interstate. They haven't straightened them out yet. That's what they're doing as they come along here. See, they just laid the cage in there.
Okay.
And the cage is loose, and then now they'll come by here and you see all those will be all straight.
Okay. And these two inside are...
That's for they call those transverse ties, for pulling the box beams together. This is all the welding here will go on Yeah, they're not welding anything right now. But as you see, what happens is on some of these beams, they're not all straight. Sometimes they have skews at the end. They have to build that skew right in there. And, right. Because the bridge might be going like this. So you don't build them straight like that. You build them all skewed so all the pieces go the same way. Once a piece is manufactured in here, they pick it up, put it on a truck. Quality control looks at it before it gets poured. Quality control looks at it after it gets poured. They bring it out to the yard, and it'll sit out there, and then they'll do any kind of little patching or cosmetic work that has to be done out here. And then what'll happen is quality control will come one more time before it ships, and they'll put a tag on it. They put a green tag on it, that means the piece can go. If they put a red tag on it, that means it's rejected. If they put an orange tag on it, that means it has to be something has to be done to it.
If it's passed, good.
Pardon?
If it's passing, they just leave it?
No, they still mark it. If it passes, they put a green tag on it. That means it can go.
Where is PCI?
PCI comes into this plant twice a year, unannounced. They could show up today and say, I want to see all your quality control records. I want to see your batching records. I want to see, you know, your shop drawings, your piece tickets, everything else. Then they evaluate each one of those things. The same day, they'll come out and check our batch plant. They'll check the batch plant operator. They'll see that he's not changing tickets or anything else like that. They'll check all the inspection reports, and then they will physically come out and measure those bars to make sure they're in the right spot. Remember I told you folks, when you cut the strands on pre-stress, it bends up. See that beam, how it's cambered up like that? That's because of the pre-stressed beams or the pre-stressed strand inside the piece. If it didn't have strand in there and it was that long, that piece would go like this.
On their own weight.
Under their own weight. But when you put pre-stressing in, you're putting artificial stresses into that piece to hold that camber. It's designed to have so much camber in there because when they put a road on top of it, it'll come down to a certain point. And then when the trucks go over, if you're ever on a bridge, bridges go like this.
Yeah.
That piece is designed to bounce.
That's not bad at all.
Okay? Questions? You ready for the test?
Your precast and prestress pretty much 50-50 of your
No.
operation? No.
No. This plant it's probably 80% transportation, 20% other products. By other products, I mean housing and stuff like that. Now it's, unfortunately, 100% transportation because the housing market's gone.
It's good that you have both of them.
Yeah, that's one of the reasons why we split our plant up like this, because it gives us the opportunity to go when other people are shut down.